give a little bit of time for people to join the stream. I'll wait like a minute, or I'll just talk to an empty room. All right, I'm going to go ahead and start so we can get through all of this stuff. So the next topic, it is solving radical equations. Okay, that's equations that have things like square roots. Actually, that's the only root we're going to talk about. An extraneous solution. This is an important feature we're going to talk about here along with it. That's a value that arises from the algebraic method of solving, but is not a solution to the radical equation. Okay, that's something we're going to be checking for every time we get an answer. All right, basically what it's saying is you did no mistakes, there are no problems at all, everything was done correctly, but for whatever reason the answer that you got doesn't end up working. Okay, here's the steps. Step 1, isolate the radical, get it by itself. Raise each side of the equation to the appropriate power to eliminate the radical, and then solve like you normally would. So in the case of these, it's going to be, yes, there are blank notes for this up on Schoology. They are in the new folder I put up today. Yeah, all the ones we're doing, the power is going to be 2. All right, so here's this guy right here. Remember, the first step is to get the radical by itself. This piece here is the radical, okay? Everything, the symbol, and all the stuff underneath it. So what we're going to want to do is get it alone by adding 3 to both sides. Okay? Now that it is by itself, we do this next part. It's the one for number 3. Raise each side to the appropriate power. This is a square root. So we're going to square both sides. Over here, the square and the square root cancel out, so you're left with what was used to be the radicand. And then 10 squared is 100. Okay. Sorry, I was just trying to get the dog quiet there. Not working. Check the solution. So, we're not done yet. Plus 8. And we're looking at x equals 108. Alrighty. At this point, we do need to check. I know you've been told in math classes for like an eternity, make sure you check your work, make sure you check your work. This time it's actually going to be a good idea to do it. Well, it's always a good idea, because sometimes you will get, like I talked about before, an extraneous solution. Okay, so we'll go ahead and write the original problem, replace the x with a nice empty set of parentheses, and plug this number in. Okay, You can do it by hand or you can use a calculator. It's totally up to you. You would enter just the part on the left and see if it gives you 7 as a result. If we were to do it by hand, 108 minus 8 is 100, minus 3, square root of 100 is 10, minus 3, and yeah, it does equal 7. So the answer is x equal to 108. We did not have an extraneous solution there. All right, going further. Same idea here. The only difference at the moment is that the radical's on the right-hand side. So we'll go ahead and add 8 to both sides to get it by itself. Okay. Now that the radical is alone, we can go ahead and square both sides of the equation. Over here, the only thing that's going to happen is we get rid of the square root symbol, and then on the side is 3 squared, or 9. And now it's like an Algebra 1 problem, or really before that. Subtract 24, subtract 24, 9 minus 24 is going to give you negative 15. Equal to 3x, and then divide by 3. So we're looking at negative 5. I believe that's the answer, but again, part of the theme here is we want to check to see if there are any extraneous solutions. So we will go back to the original problem, replace the x with a nice happy pair of parentheses, and put our proposed solution inside there. Again, you could just put this entire side into the calculator and punch it in and see if it matches the negative 5. If you want to do it by hand, let's see, that's going to be negative 15 plus 24. Negative 15 plus 24 is 9. And the square root of 9 is 3. And negative 8 plus 3 is negative 5. So it checks out. Our answer here is an x that equals negative 5. Any issues with this so far? Compared to what we've been doing, it's actually, I would say, fairly straightforward compared to some of the other weirdness that we've looked at recently. Okay, we'll keep going down. Here we go. This one is not a square root, it's a cubed root. I only have this in here so you can see that the same method applies. You're not going to encounter hardly any like this, but we'll go ahead and add 2 to both sides, giving us 6 equals the cubed root of x minus 7. And this time, since it is a cubed root, we're not going to square both sides. We will cube both sides. 6 to the third, I believe that's 216. I'll check myself on that just to make sure it is. And on the right side, the same thing happens. We just get rid of the radical and you're left with this. Add 7. And you end up with 223. So I believe that's going to be the right answer, and we can check it just to be certain. That's going to be the cubed root of 223 minus 7 minus 2. 223 minus 7, that's 216. Cube root of that, minus 2. Cube root of 216 is 6, minus 2. And that does give us 4. That's what we were hoping for. Okay, no big deal. Just check and see if there's any. How did I get 223? 216 plus 7. Should make that 6 a little clearer for you. There we go. All right. This next one is a little different because there are 2 square roots, there's 2 radicals, but they're both already isolated. One's by itself on the left, one is by itself on the right. So the very first thing we're going to do is square both sides. Okay. The left side, it drops the radical. The right side drops the radical. And now what we have is your standard equation where the variable shows up on both sides. Just as a refresh for you guys, if you don't remember, there are 2 schools of thought on how to do these. You can either make sure that the variable always lands on the left-hand side, or you can always try to make sure that the variable has a positive leading coefficient. I like that method better myself, but you can go with whichever way makes you happy. Okay, so I added 2x to both sides. That gave us 4x plus 5. Subtract the 5, you've got negative 8 is 4x. And then divide by 4. So I think that the answer is going to be negative 2. Again, the only way to be absolutely certain is to go ahead and check the solution. Here we go. Negative 3 minus 2x equals square root 2x plus 5. We'll put negative 2 in both spots. And you can, check it yourself each time. The left-hand side, that's 4 minus 3, or the square root of 1. The right-hand side is going to be 5 minus 4, which, again, we've got square root of 1. So we do have the same statement on both sides. Yeah, x equals negative 2. Okay, that's going to be the vast majority of what you're looking at. But let's go ahead and take a look at 13. 13 I have worked out for you already, okay? In this case, what happened is you've got a variable that's not underneath the radical. So the rule still applies where we had to have the radical alone on one side, and then here you can see we squared both sides. Now, squaring a binomial, you're going to want to use the box if it comes up. So that's x squared minus 6x minus 6x and a positive 36. So that's where this came from. Why am I checking it? Well, I'm not sure about the why I'm doing it like that per se. I'm doing it by hand just because you can use the calculator, just type it in and get an answer right away. That's fine too. But the reason we're doing it is to check for those extraneous solutions. Okay, I know we haven't had one yet. We're about to have, I think, yeah, I believe we're about to have some extraneous solutions on this one. If not this one, it will be an upcoming one. Okay, so anyway, however you end up doing it, this time we did it by factoring, but it's no big deal. X minus 12 is 0, which means x is 12. And x minus 3 is 0, meaning x is 3. Okay? And now we need to check both of those answers. Okay? You're going to do 3x equals x minus 6. And you have to do it with the 12. And you also need to do it with the 3. Okay, so they're all set up to check. The left-hand side, the left one, the 12. 3 times 12 is going to give you 36. And 12 minus 6 is 6. Square root of 36 is 6. 6 equals 6. So 12 is a good answer. It is a solution to this problem. Let's do this one. 3 times 3 is 9. So we've got square root of 9. 3 minus 6, that's going to be a negative 3. And the square root of 9 is 3. Okay, you might remember when we talked about it before, when we were solving using the square root method, that you have to consider both the positive and the negative square roots, but that's only when you introduce that square root symbol. If the problem already has a square root symbol, you only use exactly what it says. So in this case, square root of 9 is just 3. And 3 does not equal negative 3. So this one is not a solution. The only answer is 12. Okay, so that's going to be your first experience with seeing an extraneous solution. We made no mistakes. There was no problem with that x equals 3 until we plugged it back in and it didn't work anymore. How's that doing? All right, well, then we can just keep going here. Guys, just really quick here. A radical equation that is a cube root, it will never have an extraneous solution. It's really something that's unique to square roots, or really any even root, but you're not going to have anything like 4 or 6 roots. Cool. All right, this one here, it's another one where there's a square root on both sides. In both cases, it is isolated. So when we square both sides, you've got 8x equals 7x minus 4. We'll go ahead and subtract 7x from both sides, and I've got x equals negative 4. I think. There's no mistakes there. Everything looks good. I think the answer is going to be negative 4. But we, again, have to check to see if that is an actual solution or not. So here we go. Square root, 7x minus 4. And inside both of those parentheses, we will put negative 4. Okay, well, 8 times negative 4 is negative 32. And negative 4 times 7 minus 4 is also negative 32. They do look the same, but are we allowed to take the square root of a negative number? No, we can't. In this element, excuse me, what we're doing here, there are no imaginary numbers to think about. That is not part of this. So since you cannot take the square root of a negative number, negative 4 is not the answer, and since there was nothing left, there is no solution to this one. Okay. And if there's not an issue, let's go on. This is actually a pretty short one here. Last bit, mean sustained velocity v. Okay, here we're doing a word problem. Can be determined by that equation there, v equals 6.3 times the square root of 1013 minus p, where p is the air pressure in millibars at the center of a hurricane. What is the approximate air pressure at the center of the hurricane when the mean sustained wind velocity is this number right here? Well, the velocity is v. So that's where it's going to go, right here, to replace the v. If there's a problem where there is something left, that would be, here, let me scroll back up for you. This one here, where there were 2 solutions. Now that's only going to happen if you had to do this and you end up with a quadratic, because that's the only way you're going to get 2 solutions to choose from. Okay, most of the time you're going to have just 1 solution, and then everything else that we did before then, we got only 1 solution, and every single time it did work. So there's still an answer there. I don't know if that answered what you were asking for that. Okay, so if you do have something left that checks out, then that's the answer. There's nothing else to do with. All we're doing when we're checking it is eliminating if any of our answers happen to be extraneous. All right, so this guy here, we'll do 48.6 for our V equals 6.3 square root 1013 minus p. The rule is still the same. We're going to try to get the radical by itself first. That is a times 6.3. So we'll divide by 6.3. And this is going to give us kind of a long answer. We could take it to, I don't know, 2 decimal places, let's say 7.71. And like we've been doing, we'll square both sides. (7.71 squared), and I'll go ahead and write down the entire number here. That's going to be 59.4441, which equals 1013 minus p. and get P by itself. So subtract 1013 from both sides. That gives us negative 953.5559, which is negative P. And since this is negative P equals negative that guy, just drop the negatives in both cases. You've got P equals 953.5559. All right, now what are they asking us for? What is the approximate air pressure at the center of the hurricane when the mean sustained wind velocity is 48.6 meters per second? So it's basically this number here. I'm gonna not use the whole thing since the original problem only gave us 1 decimal point. I'll use 1 decimal point in the final answer, and that is in millibars. So you've got 953.6 millibars. And yeah, that's pretty much it for that. I've got another, I did round it up. If you're talking about taking it to 954, yeah, if you wanted to go without a decimal point at all, that's fine. Since, if you remember from science, those significant figures, since the original problem gave us 1 decimal point, we're going to want to use 1 decimal point in our answer. So I rounded the 5 up to a 6. That's about it. Okay. And this last bit here, I think it's, no, yeah, it's basically the last one. Kepler's third law states P equals the square root of A cubed. P is the time that it takes a planet to go around the sun in years, and A is the planet's average distance from the sun in astronomical units. If the orbital period of Jupiter is 11.9 years, what is its distance from the sun to the nearest hundredth of an astronomical unit? Okay, so you've got 119 years, which is your P, equals the square root of A to the third. Okay, you'll start by squaring both sides. That gives us 141.61 is A to the third. And now going back to what we've done in the past, we need to get rid of that cube. So we're going to cube root both sides. Okay, and the cube root of this guy right here, you can just put it in your calculator, is going to be approximately 5.21 to the nearest hundredth. And that is our A. So we're talking about 5.21 AU, or astronomical units. Okay? How are we doing with those? All right. Well, guys, that's basically it. The other questions that I have down below here that you can see, I've got a couple of them to try out. I'm going to leave those for a Schoology conference so we can talk about those in a smaller grouping. Other than that, this is everything for the next bit of new material.